Dear students, in our previous class, we have discussed about the simplification of SOP or POS expression into its simpler form. That means minimization of Boolean expression. In that, we have discussed in algebraic method how can we reduce the given SOP expression into its simpler form to get the simplest form of logic gate. But today we are going to discuss about simplification of Boolean expression using Kannaugh map. Simplification using Kannaugh map. Simplification using Kannaugh map. Using Kannaugh map. So, truth table is a nice and natural way to represent the functions. But apart from truth table, there are some other methods also, certain other methods also available. Among them, the most important is the Kannaugh map. What is meant by Kannaugh map? Kannaugh map means Kannaugh map. Okay, this Kannaugh map can also be called as K map. K map. Kannaugh map or K map is a graphical display of fundamental products in the truth table. So in our previous classes we have discussed about the truth table. How can we get the results in the truth table and all? So there are two things we have discussed. One is min term, the another one is max term. Okay, based on these two things, based on min term and max term, we will reduce the given expression with the help of Kannaugh map into its simpler form. So, how this Kannaugh map came into existence? The Kannaugh map came into existence with the help of Maurice Kannaugh. He has originated the Kannaugh map. Maurice Kannaugh has originated the Kannaugh map or the K map. So, what is the other name for this Kannaugh map? Okay, the other name for this Kannaugh map means one way we can call this Kannaugh map as K map, and it is also called as Veach diagram. Veach diagram. Kannaugh map or K map is a graphical display of fundamental products in the truth table. In the truth table, the results what we will get, those results can be represented in Kannaugh map. Okay, that is called as, it is a graphical display of fundamental products in the truth table. Later you will come to know when I show you with the help of truth table, when I will draw the Kannaugh map, then you will come to know how the Kannaugh map can be used and how can we take help of the truth table for Kannaugh map. So this Kannaugh map has originated by Maurice Kannaugh. So his name has given to this map as Kannaugh map. This Kannaugh map can also be called as K map, okay, which is called as the Veitch diagram. You may get question for this. What is K map, or what is the other name for K map, or explain the Kannaugh map, or define the Kannaugh map? At the time you have to define Kannaugh map or the K map is the graphical display of fundamental products in the truth table. So how the Kannaugh map looks like? Kannaugh map is nothing, okay? Kannaugh map is nothing but a rectangle, okay? It is a rectangle which is made up of certain number of squares, and each square represent a min term or the max term. See here. Kannaugh map is completely depends on min term and max term. Kannaugh map is nothing. It is just a rectangle. You have seen the rectangle. It is like this, right? This is a rectangle made up of certain number of squares, which contains certain number of squares, or made up of certain number of squares, and each square represent a min term or the max term. In each square, okay, we can enter either the min term or the max term. Each square represent either the min term or the max term. This is called the Kannaugh map. Okay, for 1 mark, if question is there, you have to define just this part. Kannaugh map or K map is a graphical display of fundamental products in the truth table. This is for 1 mark. If the question is for 2 mark, then you have to define, along with this, you have to define this thing. Kannaugh map is nothing but a rectangle, okay, made up of certain number of squares. Each square represent a min term or the max term. Along with that, you can write Kannaugh map is originated by Maurice Kannaugh. Okay, Maurice Kannaugh. And Kannaugh map is also called as a K map. The other name, it means Kannaugh map can also be called as Veitch diagram. Okay, so now come, we shall see how the Kannaugh map looks like and in what way we can represent a min term or the max term in the Kannaugh map. Okay. Kannaugh map means what? It is a rectangle. Okay, rectangle can be written in any form. Okay, rectangle. Okay, made up of certain number of squares. Made up of 1, 2, 3, 4. 4 squares are there. If a Kannaugh map is of 2 variables, Kannaugh map is of 2 variables. Just I will take 2 variables as x and y. For these 2 variables, the Kannaugh map is equal to 2 to the power n, which is equal to 2 to the power, then how many variables are there? N is equal to xy. Means n is equal to 1 and 2. 2 to the power 2, which is equal to 4. Okay? Hope you have understood. Look here. This is for your understanding purpose. If we take two variables, just x and y, then how many square Kannaugh map we need to draw? So that we have to know that how many variables we have taken. Here there are two variables, x and y. Always a Kannaugh map is represented in terms of 2 to the power n. 2 to the power n. 2 is a number. N is the number of variables. N is the number of variables. N is equal to number of variables. Here, number of variables are 2, which is equal to, write down 2 as it is. Okay. This is just for your understanding purpose. Okay. Here, in place of n, write 1, 2. 2, which is equal to 2 to the 4. It means 2 to the power 2, which will become 2 into 2 is equal to 4. So, for two variables, we need to draw 4 squared Kannaugh map. Okay, 4 squared Kannaugh map. Later I will show you. We can change the variables also when needed. Okay, just you remember, if we take two variables, then at that time 4 squared Kannaugh map has to be drawn. Now I will take x this side and y this side. Okay. So, what is the rule for the min term? We are solving min term. What is the rule for the min term? The rule for the min term is put bar for 0, right? And the second one is if 1 is there, write the letter as it is. Okay. Hope you have understood. If x is equal to 0, okay, then this can be written as x bar. Okay. If the x value is 1, this can be written as x. Just like we have done. If we take 0, 1, 1, then we have to write x bar, okay, y, z. For 0, we will put a bar in min term. Okay, then for 1, we will not put, we will just write down the letters or the variables as it is. Okay, now look here. Here, we will take two values, only two variables are there, so I will take only 2. 0, okay, then 1, here also 0, then 1. Okay, this is the address of this square. Okay, like this. So, for 0, what we will write here, x is there. Concentrate here. Okay, look clearly. Here 0 and 1. Here also 0 and 1. X is there. In place of 0, what we have to write? In place of 0, we have put a bar. So, we need to write here as x bar. Okay, then here 1 is there. In place of 1, no need to put the bar. X is there. Write down x as it is. Same for y. Here 0 is there. Put y bar. Okay. Here 1 is there, so no need to put any bar, just write down y as it is. This means this is the Kannaugh map for two variables, okay, x and y, 0 and 1. For 0 put x bar and for 1 put x. For 0 put y bar, for 1 put y. Then we need to number the squares here. We need to number the square. How can we number the square? In this corner, we need to enter. We shall start from 0. 0, 1, 2, 3. Like this, we have to number the squares of Kannaugh map. Okay, this is a two variable Kannaugh map. 0, 1, 2, 3. Always you have to enter the number in this corner of the square. At the right down corner of each square, you have to enter the number. How can we represent a min term? We can represent a min term in small letter m. Okay. Yes, earlier we have discussed that min term can be expressed in small letter m. So for each box, okay, according to Kannaugh Map definition, each square represent a min term. Always it will represent a min term. So these squares have to be given the numbers and we have to give names for each square. We have to give name for each square. Look here. Here 0 is there. So first square will become m0. Okay. Then here 1 is there. The next square will become m1. Here 2 is there. So the next square will become m2. Here 3 is there. The last square will become m3. Min term 1, min term 0, min term 1, min term 2, min term 3. Like this. Small letter if we use small letter m means then it is called as min term. Okay. Here 0 is there. So the square name is m0. Here 1 is there, so square name is m1. Here 2 is there, so square name is m2. Here 3 is there, same way, square name is m3. This is how we can write a Kannaugh map. Okay. How can we get an expression with the help of this Kannaugh map? Okay, we need to get an expression. After that only we have to reduce that expression into its simpler form. Okay, with the help of this Kannaugh map. See here. For m0, okay, this is m0, the name of the first square. Okay, m0. We have to take values. What is here? X bar. X bar is there. Then write down its value y bar. First write x bar, then write y bar. Okay. After that, for this square, for m1 square, okay, write down x bar first, then write down y at next. X bar first, then y at next. Next for this square, for m2 square, this is m2. Here x is there, first write down x, then write this one. Okay, first write x, then write y bar. Okay, then for m3, one square left, that is m3. For this we have to write first x, okay, then write y. X and y. So this Kannaugh map consists of 4 products. Those products are, write down first for m0, which is equal to x bar y bar. Okay, m0. And m1. M1 is which one? This square is m1. For m1, the value is x square y. That's. Then for m2, okay, this set is number 2, this square. So it is named as m2. What is the expression here? X y bar. Then it is equal to 3 means m3. The expression is x bar. So for this Kannaugh map, okay, f is equal to, we will represent min term always by sigma. We will represent min term always by sigma. Okay, put bracket, then write 0, 1, 2, 3. 0, okay, 1, 2, 3, which is equal to, what is 0? 0 means m0 plus, okay, 1. 1 means m1 plus 2. 2 means m2. m2 plus, here 3 means m3. Okay, we are doing SOP form, sum of product. Okay, we are using min terms here. So for that we are using small letter m, and in between these products, there is a or operator. Okay. Now write down the expression. For M0, what is there? X bar plus Y bar. X bar Y bar plus, okay. For M1, X bar Y. X bar Y plus. For M2, X Y bar. X Y bar plus. For M3, X Y. Like this, we can get an expression for the Kannaugh map. This is just the example I have shown you. And now later, after this, we will discuss how can we get a particular expression. This is an example for you. How to draw the Kannaugh map, okay, and how to number the Kannaugh map, okay, how to name the Kannaugh map, okay, 0, 1, 0, 1. 0 means X bar in min terms, okay, only in min term for SOP. X bar, then for 1 X, Y bar for 0, Y for 1. Then write values here or write the expression. First write X bar, then write down Y bar. Then for this square, first write X bar, then write Y here. Then for this square, it means M2, okay. X, write down X here, then write down this one, Y bar. Okay, after that, write X here, then write Y here, like that. Okay, then write down M0. M0 is equal to X bar, Y bar. Then M1. M1 equals X bar, Y. Okay, this one. M2. M2 is this one. Okay, write down value X, Y bar. X, Y bar, write down here. M3 is this one. For M3, value is X, Y, write down X, Y. It can be represented as F is equal to sigma of 0, 1, 2, 3. Okay, because 0, 1, 2, 3. For that, for 0, M0, then write plus M1 in place of 1, M2 in place of 2, in place of 3, write M3. Okay, then M0 is X bar Y bar plus M1 is X bar Y plus M2 is X Y bar plus M3 is X bar. Like this, we can represent a Kannaugh map. Now, after this, this is for two variable Kannaugh map. Now, I will take three variables. So, for three variables, how can we represent a Kannaugh map? This is the simplest form because we have taken just two variables here. So, for this 4 squared Kannaugh map, we will draw and we will represent values in easiest way. Now, come, we shall take the three variables here. How can we write the Kannaugh map for three variables? This method is, okay, sum of product reduction using K-map. Reduction using K-map of Kannaugh map. K-map or Kannaugh map. Sum of product reduction using Kannaugh map. Okay, we are doing this only. Now I will take three variables X, Y, and Z. For this three variable, how can we write? How we have to write the Kannaugh map? Look here. For three variables, okay. How many number of variables are there? 3 here. This is equal to 3. Okay. Then Kannaugh map can always be taken as 2 to the power of n, which is equal to, okay, 2 to the power of 3. Okay, which is equal to 2 into 2 into 2. Okay, that is equal to 2 to the 4 into 2 into 2, which is equal to 4 to the 8. Variables. Okay, 2 to the, always take 2 to the power n. Okay, if we take 2 to the power n, then in place of n, take number of variables. N equals 3. N equals number of variables. Here 3 variables are there. So n equals 3. Then put 2 In place of n, put 3. 2 cube means 2 into 2 into 2. Okay? 2 into 2, 4. 2 2s are 4. Into 2, write down as it is. Then 4 2s are 8. So we have to write a 8 squared Kannaugh map for 3 variables. How many squared? 8 squared. We need to remember this thing clearly. Okay? If we get the exact number of squares, then only we can able to simplify the expression into its simpler form. Now I will write Kannaugh map for x, y, z. 8 number of squares. How can we write 8 number of squares here? Write like this. Okay. We have to write like this. 8 squared Kannaugh map. See, 2, 4, 6, 8. How can we represent this? Here, write x here, then y and z this side. Okay? X is always at right side, then y and z is at, so x is at left side, then y and z is at right side. Okay? This side we will take values, just one variable is there, x. So we will take 0, then 1. Because only one variable is there. So we will take only two values here. But here there are two variables, y and z. So we will take two values, 0, 0. Okay, look here. Now you have to concentrate here clearly. In two variable, that means 4 squared Kannaugh map, numbering and naming is very much easier. But in 8 square Kannaugh map, it is little bit different. Okay, 0, 0 first, then 0, 1. 0 0 0 1. After that, okay, how will you take? Just I will show you x and y. Okay, truth table. I will write truth table for two variables. Okay, write for 3. Okay, how many values will take for 3 variables? 8 values. 1 2 3 4. 1 2 3 4. Okay, then for y we will take 0 0 1 1 0 0 1. Then for z 0 1 0 1 0 1 0. Now we have to write. How? First take these two. We have completed x already because only one is there, but two boxes are there. So just take two things, 0 and 1. Here two are there, so we have to take these two combinations at first. 0 0. So put 0 0 first. Next is 0 1. Okay, put 0 1 first. After that, here you have to mention the name clearly. 0 0 finished, 0 1 finished, then 1 0 is there. No need to write here, write this 1 0 in this place. This is the rule of Kannaugh map for 8 squared Kannaugh map. Okay, 0 0 0 1. Okay, 1 0. Now 1 1 is there, write down 1 1 this side. Like this, we have to name the squares of a 8 squared Kannaugh map. 8 squared Kannaugh map. After that, okay, here we have to number the squares. In numbering squares also, put 0 here, okay, then 1, okay, then write 2 here, then 3. Like this, you have to number. Then 4, 5, okay, put 6 here, then 7. Like this, you have to number. Okay, for these cells, okay, how will you take m0, okay, then m1, okay, m3, okay, then m2. Okay, this is horizontal. And for this, then M4, okay, M5 for this square, okay, then M6, sorry, M7 is there, M7, okay, then M6. Like this, we have to give the names and we have to give the numbers here. For 8 squared Kannaugh Map. Okay. Then here x is there. How will you write? For 0, we will take x bar. For 1, we will write just x. Okay, here two zeros are there, so we need to write y bar, z bar. In place of 0, we will write bar. Here 1 0 is there, so write y bar. In place of 1, write z. Here 1 1 is there, write y z. Here 1 and 0 is there, write y, then z bar. Okay, this first letter of every, okay, square will represent the first letter y. Okay, first letter of every square represent first letter y. Then second letter of every square represent the second thing z. Okay, z of 0, z, 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 like this. Now write the, give the expressions of every square here. Okay, first write x bar, okay, then write y bar, z bar. Always take from left side. Then for this, write x bar first, then write y bar, then z. Okay, then for this, write x bar first, then write y, z. After that, for the last, write this one first, x bar, then y, then z bar. Now come to next row. Here x is there, write x first, then write these letters or these literals, y bar, z bar. Okay, then write x here, then take these two, y bar, z. Then write x here, then take these two, y, z. Okay, then write x here, then take these two, y, z bar, y, z bar. Like this, we can give the expressions, or then we can give the expressions or the literals or the product or the min terms. Okay, we can call them as min terms. Min terms for every square. As Kannaugh Map states, every square represents a min term or the max term. So we are doing sum of product. Sum of product means here each square contain one min term. So the value of m0 means 0 here. It is x bar, y bar, z bar. X bar, y bar, z bar. Okay, and for m1, for m1 we have to take value from the square number 1. X bar, y bar, z. X bar, y bar, z. Okay, then for this third one, m3 is there, so take m3, x bar, y, z. X bar, y, z. Okay, then for m2, okay, write down this, x bar, y, z bar. X bar, y, z bar. Then for this square, for 4, here for m4 we have to take the min term of fourth, okay, number 4 square, x, y bar, z bar. X, y bar, z bar. Here m5 is there, we have to take the min term from number 5 square, x, y bar, z. X, y bar, z. Then m7 is there, for m7 we have to take the min term from number 7 square, x, y, z. X, y, z. Okay, m6 is there, so we have to take the min term from the 6 numbered square, that is x, y, z bar. X, y, z bar. So like this, we have to take the min terms. We have to create min terms for the 8 squared Kannaugh map. So here we will take, how can we represent this? Okay, always represent with f is equal to sigma. Mean terms are always represented by sigma into 0, 1, 2, 3, 4, 5 and 6. Okay, 0, 1, 2, 3, 4, 5, 6 and 7 we have to take here. 7. Okay, this is completely one expression. Complete one thing this one. So if you are getting confused, I'll write a little bit down or I'll write this side. See, F is equal to sigma into, okay, 0, 1, 2, 3, 4, 5, 6, 7. Okay, 0, 1, 2, 3, 4, 5, 6 and 7. Then which is equal to m0 plus m1 plus m2 plus m3 plus m4 plus m5 plus m6 plus m7. Okay, remember one thing. Always we have to represent the square number in terms of subscript. Subscript means below m we have to write. No need to write like this. M0, M1, okay, M2. This is wrong method. Don't write like this. Always write the number below the letter. M0 plus M1 plus M2 like this. This is right. Okay. Then one more thing you need to remember here. Here I have taken M0, M1, M3, M2, M4, M5, M7, M6. According to rows I have taken. But while deriving the expression, while simplifying the expression, you need to take order wise. Just like 0, 1, 2, 3, 4, 5, 6, 7. Like that. M0, M1, M2, M3, M4, M5, M6, M7. Like this you have to take. Okay. Go with serial. Don't change the number as square. Okay, go with serial. 0, 1, 2, 3, 4, 5, 6, 7. Now I will write expression for this, or I will write min terms of every every square here. M0, okay, x bar, y bar, z bar. Okay, x bar, y bar, z bar plus M1, x bar, y bar, z. X bar, y bar, z plus m2. Okay, you have to remember here m2 for this square we need to write this one, x bar, y, z bar, x bar, y, z bar plus then m3. Okay, for m3 here number 3 square, x bar, y, z, x bar, y, z plus then m4. Okay, m4 is here. Okay, x, y bar, z bar, x, y bar, z bar. Then m5. M5 is there for this, right? This square min term x, y bar, z. X, y bar, z. Plus then m6 is there. So we have to see m6 is here. This one. 6 numbered square is called as m6. Write down x, y, z bar. X, y, z bar. Plus, okay. Then m7 is there. 7 numbered square is there. We have to write this one, x, y, z. X, y, z. Like this we can represent the 8 squared or the 3 variable Kannaugh map. If we try in this way, then definitely we can get the exact answer or the exact result. So one thing here you need to remember. What that thing means? Okay, I will rub this one and I will show you. Okay, this number we will take here. Okay, what is that? 0, 0, 0, 1. Okay, then 1, 1, 1, 1, 1, 0. Okay, orderly it should be like this only, 0, 0, 0, 1, 1, 1, 1, 0. This number is called as gray code, Gray. Don't write Grey. Okay, gray code. Okay, this is more important for your exam. It may be asked for 1 mark. Write the gray code or give the example of gray code. After that, question may be like this: explain gray code or what is gray code. No, I will write here. Gray code is the binary number. Gray code. Gray code is the binary code. Gray code is the binary code in which each successive number differs only in one place. Only in one place. Okay. If you get a question, what is gray code? You may get. Okay. I'm sure. Maybe this year this question will be asked for 1 mark, or maybe for 2 mark. Write gray code and give an example for gray code. So at that time, gray code is the binary code. It is binary code 00011110. Gray code is the binary code in which each successive number, okay, is differs only in one place. Just one place the number is going to be changed. It means 0001. After 01, 10 has to come. Okay, but here number is going changing. After 10, 11 has to come. After 01, 10 will be, has to come. Then after 10, 11 has to come. Okay, but here 1 differs only in one place, means after 01 directly 11 is coming, then after that 10 is coming. So this type of code is called as the gray code. Okay, so you need to remember this gray code is the binary code in which each successive numbers differs only in one place. Like this, we have to draw the Kannaugh map. Now I'm going to write a Kannaugh map for 4 variables or the 4 literals. So come, we shall see how a 4 variable Kannaugh map can be represented. How it looks like. Okay, you have seen the first one, that is 2 variable Kannaugh map, and the next one is 3 variable Kannaugh map. Now I will take it as WXYZ, 4 variables. So how can we draw or how can we represent these 4 variables in a Kannaugh map? So you need to go for that. Okay, n is equal to 1, 2, 3, 4, 4. Okay, then 2 to the power n, which is equal to 2 to the power 4. 2 to the power 4. N is equal to 4. Then here we'll take 2 to the power of n. Then n is equal to 4. So put in place of n, put 4 here. Now multiply. 1, 2, 3, 4. Okay, multiply 2 4 times. Okay, which is equal to 2 to the 4. Okay, into here 2 to the 4. Okay, then into 2 into 2, which is equal to 4 to the 8. Okay, this is finished. Into 2, which is equal to 8 to the 16. 16 squares we have to draw the Kannaugh map in 16 squared Kannaugh map. Now I am going to draw the Kannaugh map of 16 squares. Hope you have understood this. Now I need space. For that I am going to rub this. Okay, 16 squared. Okay, leave some gap here so that we can write down values easily. Okay, 1, okay, 2, 3, like this. 1, 2, 3, then 4. If we take 4 columns and 4 rows, then this will become 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So represent here Wx, then Y, Z. Okay, Wx, Y, Z. So here, how can we give numbers for, okay, 16 squared Kannaugh map, that is 4 variable Kannaugh map? How can we give numbers here? We have learned how to give numbers in 2 variable Kannaugh map, and we have learned in 3 variable Kannaugh map, that is 8 squared Kannaugh map. Now we have to give numbers for 16 squared Kannaugh map. How can we enter? Look here with complete concentration. Same as in 8 variable Kannaugh map, how we did there, same way we will use here, but little different. 0, 1. Okay. Then where is 2? 2 is in last. Then write 3 here. Okay. 1, 2, 0, 1, 2, 3. Then write 4, 5, 6 here, then 7. Okay. After that, leave this row, come to here. After 7, 8, 9. Okay. 10, 11. 8, 9, 10, 11. Then at last come to here. After 11, 12, 13. Then write 14 here. Then 15 here. Like this, we have to enter numbers for the 16 squared, that is 4 variable Kannaugh map. 0, 1, 2 at last, then 3. Come to next row. 4, 5, 6 in last, then 7. After that, leave this, come to last row. 8, 9, 10, then 11. After that, come to the above step. 12, 13, 14, 15. Totally 16. So here Wx. So I think you have understood this, how to number. Here Wx is there. Wx means 2 variables are there. So what will we do? We will take 2 zeros. 0, 0. Okay. 0, 1. Okay. Here also what we will do? What we will do here? After 0, 1, we need to come down. Okay. 1, 0. Then we will write 1, 1 here. Same here. 0, 0. Then 0, 1. Okay. Come to last. 1, 0. Then 1, 1. Like this we have to number. Here giving names 0, 1, 1. 0, 0, 0, 1. Then 1, 0. Then 1, 1. Here 0, 0, 0, 1. After that 1, 0, 1, 1. Okay. We are using for SOP, sum of product. It means min terms we have to represent. So in place of 0, we will put bar. Okay. Wx here. W bar, X bar. 2 zeros are there, so 2 bars. Here 1, 0, 1 is 1. Then W bar, then X. Okay. Then here both are ones, right? Wx. Here for 1, W, for 0, X bar. Okay. Here for this, just change the letters. Y bar, Z bar. Here we have taken W bar, X bar. Here Y bar, Z bar. Then Y bar Z, because for 0 we have to put bar, for 1 no need to put. Take YZ. Okay, here both are 1, so Y and Z. Okay, here 1 is 0. Okay, 1, 0. Okay, first one is 1, so write Y. Next one is 0, so put bar. Like this. Okay, then what are the min terms we have to write here? How can we name the cells here? We name the cells as M0, M1, okay, M0, M1, then M3, Okay, or you can write it as m2, but while writing the minterms you have to write clearly m3. Okay, then m4, m5, m6, m7. Okay, this is small letter m. Then m8, m9, then m10, m11, then m12, then m13, then m14, at last m15. m15. Like this we have to write. So for first square, how will you write? First write this one, w bar x bar, w bar x bar, then write this one, y bar z bar, y bar z bar. Okay, after that for this square, first write w bar x bar, w bar x bar, then write this one, y bar z, y bar z. Okay, then for this one, okay, first write w bar x bar, first write w bar x bar, w bar x bar, then write y z. Always take the number from the terms from left side, then take terms from top. For this square, w bar x bar, w bar x bar, then write this, the y z bar. Next come to next row, w bar x, w bar x, then y bar z bar, y bar z bar. Next w bar x from here, then y bar z, y bar z. Next w bar x from here, w bar x from here, y z, y z. Next w bar x from here, then y z bar, y z bar. Come to next w x, y bar z bar, y bar z bar. Then w x, y bar z, y bar z. Then w x, y z. After that w x, y z bar, w x, y z bar. Okay, for last w x bar, y bar z bar. Then w x bar, y bar z. Then w x bar, y z. Okay, then w x bar, y z bar, y z bar. Like this you have to write mean terms for every square. Now write down all the mean terms for these letters or these squares. For m0, write from 0, w bar x bar, y bar z bar, w bar x bar, y bar z bar. Okay, for m1, write from 1, w bar x bar, y bar z, w bar x bar, y bar z. Okay, then for m2, okay, remember here m2, write from number 2 square, w bar x bar, y z bar, w bar x bar, y z bar. Okay, then for m3, okay, come to this side, 3 numbered square is here, right from here, w bar x bar, y z, w bar x bar, y z. Then for m4, right from here, w bar x, y bar, z bar, w bar x, y bar, z bar. Okay, then for m5, right from number 5 square, w bar x, y bar, z, w bar x, y bar, z. Then for m6, okay, remember here for m6 we need to write from this square because number 6 is here. Okay, w bar x, y, z bar, w bar x, y, z bar. Okay, then for m7 come this side because 7 is here. This is m7. Write down here w bar x, y, z. That is equal to w bar x, y, z. Okay, then come to m8. Where is m8? m8 is at last. So write down from here. W x bar y bar z bar. Okay, W x bar y bar z bar. Then for m9, okay, right from number 9. This is m9. W x bar y bar z. W x bar y bar z. Okay. Then m10. Remember m10. So 10 is here, right from here. W x bar y z bar. W x bar y z bar. Okay, after that m11. m11 is beside 10. Here is 11. W x bar y z. W x bar y z. Then m12. Okay, where is m12? m12 is here. 12. Number 12 square is here. So we have to write m12. W x y bar z bar. W x y bar z bar. M13. M13 is next to this. W x y bar z. W x y bar z. Okay. Then after that m14 is there. Where is m14? m14 is here. Okay, because 14 number is here. W x y z bar. W x y z bar. At last m15 is there. 15 is beside 14. Come to here. Then write W x y z. W x y z. Like this, we have to write a 4 variable. That means 16 squared Kannaugh map. Only these are the 3 ways of writing Kannaugh map. But after writing and while writing, we need to remember to enter numbers. In which way we have to number? For 2 variable, 4 squared. For 4 squared Kannaugh map, only 4 are there. Okay. So just write 0, 1, 2, 3 directly. You can write directly here. No problem. Okay. This is simpler. Then after this, 3 variable Kannaugh map, you have to number and name clearly. And 4 variable Kannaugh map, that is 16 squared Kannaugh map. For this, you have to number it clearly. Okay. Hope you have understood this. And how can we represent this? We can represent this as f is equal to sigma, because mean terms we will represent sigma. Okay, write down up to 16. 0, 1 up to 15. Okay, 2, 3, 4, 5, 6, 7, 8. Okay, 9, 10, 11, 12, 13, 14 and 15. Okay, 0 to 15. Okay, but here order is different. While writing, we can write in serial number, which is equal to, okay, how can we take m0 plus m1 plus m2 plus m3 plus m4, okay, like this, plus m5 plus m6 plus m7 plus m8, okay, plus m9 plus m10 plus m11 plus m12, okay, plus m13 plus m14 plus m15. Like this we have to write. Then now we will try to write the minterms of these expressions for these numbers. Okay, what is for m0? For 0, w bar x, take from here only, w bar x bar y bar z bar, w bar x bar y bar z bar, plus for m1 is w bar x bar y bar z, w bar x bar y bar z. And for m2 is w bar x bar y z bar, w bar x bar y z bar. Okay, plus m0, m1, m2. Now for m3 w bar x bar y z, w bar x bar y z, plus then m4 w bar x y bar z bar, w bar x y bar z bar, plus. Okay, then m5 is w bar x y bar z, w bar x y bar z plus, then m6 is w bar x y z bar, w bar x y z bar plus, then m7 w bar x y z, w bar x y z plus. Okay, then m7, after that m8 is there. Okay, m8 is w x bar y bar z bar, w x bar y bar z bar plus m9. Okay, m9 is w x bar y bar z, w x bar y bar z plus, then m10 is w x bar y z bar, w x bar y z bar plus, then m11. Okay, m11 is w x bar y z, w x bar y z plus, then m12 is w x y bar z bar, w x y bar z bar plus, then m13. Okay, m13 is w x y bar z, w x y bar z plus m14 is w x y z bar, w x y z bar plus m15 is w x y z, w x y z. Like this we have to write the expression. This is the method of writing. I'm showing you the example how to write the expressions, how to give the min-term numbers, and how to number the squares. Okay, and how to write min-terms of squares, and how to give the gray code, and all these things I'm showing you the example. Okay, how to create the Kannaugh map and all. Okay, later we will get some values for the Kannaugh map. Then at that time we can derive the expression by those values which will get inside the Kannaugh map. In our next class we shall solve some problems, some Kannaugh map problems. By Kannaugh map we will take some expressions and we will reduce those expressions into their simplest form. Okay, regarding this, if you have any doubts you can ask me personally. Thank you.